Hey you guys, today we're going to be working on concept 16, looking at directly and inversely proportional relationships. Wow, that looks like a lot. Well, it's pretty easy. So level 1, we want to be able to identify inversely proportional relationships. And we'll get into that right now. It's pretty easy. All right. If you look, I'm going to, instead of looking at proportional and non-proportional, now we're going to look at two types of proportional relationships. There's a directly, or what we usually just call a proportional relationship, and an inversely proportional relationship. So we want to be able to look at the graph today, down here when we get there. What is the graph going to look like? We've studied proportional relationships in the last concept. Now we want to look at two different types, and they're basically going to do the opposite things for the most part. And so I set up a story, an equation, and we'll look at a table and a graph. We'll go a little deeper in the next concept and really dig into how to set things up and how to write equations and look at tables. But for now, we really want to focus on the graph and what the graph is about. All right, let's look at the story between proportional review. Austin wants to earn some money this summer by working at the resort. He gets paid $8 an hour. Okay, there's nothing added on, so that makes it a proportional relationship. And it's the rate is $8 per hour, and that would be my total dollars that he's going to earn. And if I set up a table here and we graph it, so if he works 1 hour, he's got $8. That's this point. 2 hours, 16. It makes a straight line, and it goes through 0, 0. Okay, so in my table, again, take the y divided by the x, and you can see that it's always going to equal 8. So for looking at the table, just remember, take the y divided by the x. Okay, remember those concepts. That's going to equal that slope, or that unit rate that we call m. Okay, all right, let's look at how the inversely proportional, and let's look at the graph. Basically, it says Arnold likes to show how strong he is by carrying people on his back. The more people Arnold carries on his back, the slower he walks. So here's the equation now. Let's jump back. I saw a video here last night where they talked about a proportional and an inversely proportional relationship. And to make it as easy as possible, now I want to talk about if we just keep this rate of change, or that constant, I want to keep it positive. So we just want to basically keep things in the first quadrant here. Now there's a curveball in here, but we'll just keep it positive, keep it simple, keep it easy. So if you look at a proportional relationship, assuming I keep my constant the same, they had steps, kids going up the steps. So draw some steps here. And if they had a proportional relationship, they had one guy moving up the steps and the other moving up at the same time. Okay, here for example, look, if I double 2 to 4, look at my answers for the total cost. If 2 doubles to 4, 16 doubles to 32. It's got to stay proportional. They're both moving. When my unit rate's positive, they're both going to go up and up. Okay, on the inversely, just what inverse really means. It means the opposite. So if I have some steps, draw some steps here. If I have some steps going upstairs, then one boy was going up and the other boy was coming down at the same rate. He was going up, he was coming down at the same rate. That's what inverse is going to do. Okay, inverse is going to be doing the opposite. It's going to be doing this. Okay, whereas proportional, usually when we're looking in the first quadrant and it's a positive unit rate, they're both going to be going up. So let's look at a table and a graph here quick. All right, if I take one person, so I put 1 right here. If I take 12 divided by 1 right here, 12 divided by 1, I'm going to get 12. So if he carries one person, he's going to go 12, let's say 12 miles per hour. That's pretty fast. And then let's say he takes 2. So if I put 2 for the people here, 12 divided by 2 is 6. So as he carries more people, he slows down. So as this gets bigger, this is going to get smaller. And that's the inverse. Now if I graph these, if I go over 1, up 12, put a dot, over 2, up 6, and I keep the graph like my beautiful line here. So I kind of connect all the dots. It's not going to make a straight line like a proportional does, and it doesn't go through the origin. So you just have to memorize this. It's going to make a curved line. And so basically, again, as this person walks down the steps, this person's going to walk, or excuse me, as this person goes up the steps, this person's going to come down the steps. That's what inversely proportional equation is going to look like. And we'll go more deeper into the equation. But for now, just remember the graph is going to make a curve. Doesn't go through 0 like this one, like the proportional does. All right? All right, we'll catch you later. Take it easy.